My name is Aurora. I'm a postdoc at the University of Murcia, and my work focuses on artificial intelligence for smart environment. This is what I will talk about today. So my research consists basically on two main areas that are related. On the one hand, I develop basic research, or I do basic research. I develop algorithms and methodologies to solve real data problems regarding the reduction of their volume, imputing missing values, and federated and transfer learning. And then on the other hand, I use and adapt such methodologies for another AI-based ones to extract knowledge from sensorized environments in order to create new services that are automatic or improve the existing ones. So the areas of application are IoT verticals, such as buildings, agriculture, transportation, and security. And the developments that I will briefly present here are published already. So the references to those works are highlighted in black through the presentation. And let me start with the first case. For basic research, I will describe the main lines of work. The first one is related to finding optimal ways to reduce the data points of a time series while preserving the key characteristics of the data. So basically, we created an algorithm called bits that, roughly speaking, splits the data into streams, the data streams into blocks, computes the DCT, the discrete cosine transformation, and then makes some more calculations, getting at the end the modulus of the eigenvalues of the final matrix as the representatives of the time series. So comparing classification and clustering results using raw data and the transform data, we obtain obviously better results in computing time, and many times the accuracy was kept the same or even improved in some of the cases. And we have currently submitted work with a multivariate version of this algorithm. Then another line of work related to data problems is missing value imputation in multivariate systems. We have developed a model that is based on Bayesian maximum entropy and allows the incorporation of knowledge regarding how accurate the sensor is, like hard sensors or soft sensors. The methodology accounts for the geolocalization of the sensors as well. And this has been, we have created a web application, and here there are some demos about it. We are also very much interested in federated learning, which has been already introduced in this session or in the previous one. But basically, you know that it enables training machine learning while maintaining machine learning models on a decentralized way while maintaining data privacy. So we have created a multi-class classifier for detecting attack types and applied it in the Tone IoT dataset, for example. We have also analyzed the impact of non-identically independently distributed data. Consider also different aggregation methods such as fed average, fed plus, and also we have worked on differential privacy as well so far. And indeed, we have identified several challenges in federated learning scenarios, and we try to tackle some of them bit by bit. For example, at this moment, we're working on defining new aggregation functions and on unsupervised federated methods as well. And finally, as for the basic lines of research, transfer learning is another of my lines of work. And the idea of transfer learning is to use the knowledge gained on specific use the knowledge gained on a particular task in another similar or related task or from a similar domain. We have created a methodology based on, first of all, we cluster the individuals using their metadata, not the dynamic data, but the characteristics. we train some deep network like convolutional or LSTM, depending on the proposed on the work that is going to be applied on, but some deep neural network using all data of the centroid of this cluster, and then transfer the model to the rest of the individuals of the same cluster. And we show that using less data from these individuals, we still get very good results regarding the prediction and the accuracy. So far we have been transferring the weights of these networks, but we want to try other strategies as well. And as for the second part, or the other line of the other main line of research, which are methodologies to extract patterns towards the creation of smart services in the Internet of Things verticals. Let me describe some of the environments that we've been working with. So first, we have been focusing on improving buildings, to make them smart in the sense of energy efficient. We have done energy consumption prediction works using machine learning. We have studied how to select some features, which kind of models like black box, gray boxes, white box are better, time series modeling as well. And we have studied also patterns on the HVAC usage, like the heating, ventilation, and air conditioning, in order to give personalized recommendation to the users according to their profiles. We have used data that is of the type of set points of the HVACs, or how the user intervenes with the set points, how many times a day, how many hours they have it turned on. And also recently we have published an open data set with a year of data from a smart building in Murcia, and also some works on demand response, which is a strategy used to manage and balance electricity demand during periods of great stress. That's for smart buildings. We have also many scenarios in smart cities in general, as it is the case of water management. Here we have collaborated with regional institutions for detecting anomalies in water consumption using traditional statistical methods such as ARIMAS and machine learning as well, in order to find different patterns. Also some strategies to, again, extract knowledge of the data using symbolic aggregate approximation, which can be compared with bits, the original work that I talked about first. Thirdly, smart agriculture is another field where we have had some projects and advances. We have published a framework to deal with all the process from data collection to data fusion and analysis applied to a smart greenhouse. So the idea or the service we provided was to select automatically the climatic systems according to the environmental context. And this platform is connected to the algorithms that are available through APIs created by means of OpenCPU and other packages. As regarding smart agriculture, we have also studied satellite images for NDVI estimation of a piece of land and weed identification using images by means of CNNs, and those works are currently under review. And finally, I am currently focusing on a specific case in my region, that is the creation of a digital twin of a lagoon and its basin that is called Mar Menor. It's a complex ecosystem that we want to understand from a data perspective in order to make realistic changes towards its preservation. And these are the references. That's all. Thank you for your attention.